let's suppose we have a decision tree that we just have an outcome here. We have probabilities here. So based on states of nature, based on this alternative. And these involve follow-on decisions that might involve further probabilities towards outcomes, or they just may result in an outcome. And let's just do the same thing down here. So this decision results in an outcome or states of nature or state of nature. And then so from the top we have a value, let's say A. We have a probability or a value B, C, D, E, F, and G. So the question is, what decision should we make? So here's how we do this. We're actually going to start on this end out here on the right. And we're going to do it by computing EMVs where we can, and then comparing values. So with decision trees, we either want to minimize cost or max profit. Now, there's other things we want to do, but when we're dealing with expected monetary values, EMVs, we want to do one, not both of these things. So, let's suppose that with this example, we're minimizing cost. So, we're going to compute this EMV. That's going to give us a value here. Let's just call this EMV of FG. And we know how to do that. That's this probability times F plus this probability times G. And that gives us a value here. We're just going to say it's EMV FG. Well, and we should have a value here for E. And let's, in this case, just suppose that the value for E is the lower of the two. So that's going to go here. And conversely, we could do this here. We'll call this EMV BC. And we'll call this value C, or D, sorry. Call this value D. And we would do the same thing. We would compare this value with this value. And let's just say for this example, this value is less. Again, we're minimizing costs. So this would put this value back here, EMVBC. Now, we should have probabilities here because this involves states of nature. So we would compute the EMV of these two values the same way we compute any other EMV. And that's going to give us an EMV for those two. And we'll just call this BCE. But just to reinforce that point, with this example, we'll call this probability A and probability B. The EMV of BCE would equal the EMV of BC times the probability of A, or whatever A is. So that value, A is a probability, so it would be A times EMV BC plus the same down here. So B, which is a probability, times value E. And that would give us this value here. And the last thing we would do is compare that value with this value. And whatever is the lowest, because we're minimizing cost, that would be the decision that we would make. So let's just say in this case A is lowest, so that means we would choose this alternative for our decision. And that's how we collapse a decision tree.